Close your eyes. Let yourself drift through the vast darkness of space. Here, in the endless night between worlds, you discover something magnificent. A star. Your star. It hangs before you like a glowing pearl in black velvet. Warm, steady, beautiful beyond words. This is not just any star. This is a giant, many times larger than our own sun. It has been burning for millions of years, and it will burn for millions more. But tonight you get to see inside. You move closer. The star's light grows brighter, but it doesn't hurt your eyes. Instead, it welcomes you, wraps around you like a gentle embrace. You can feel its warmth on your face. Its glow fills your heart with wonder. This star is alive. Not alive like you or me, but alive in its own cosmic way. It breathes. It has a heartbeat. Its pulse echoes through space, slow and deep and steady. Each beat takes thousands of years. Each breath lasts longer than entire civilizations. You drift closer still. The star's surface ripples like a golden ocean. Waves of light dance across its face. Some waves are small, like gentle ripples on a pond. Others are massive, towering higher than mountains. But all of them move with grace, with purpose. Now you begin to sink inside. The star's outer layer welcomes you like warm water. Here, the temperature is comfortable, about as hot as a summer day on Earth. The light around you is soft, golden. It reminds you of honey or sunset or the glow of a fireplace on a winter evening. But as you drift deeper, things begin to change. The light grows brighter. The warmth increases, not harsh or burning, but like sinking into a perfect bath. The pressure builds gently around you, like being hugged by invisible arms. You feel safe here, protected. The star knows you belong. Deeper you go, thousands of miles down. The temperature rises to hundreds of degrees, then thousands. But somehow, you remain comfortable. You are a visitor here, welcomed by forces beyond imagination. The light changes color as you descend, from golden yellow to brilliant white, from white to pale blue. The star is showing you its secrets, layer by layer. Each zone has its own personality, its own rhythm, its own role in the cosmic dance. You pass through regions where the star's material moves in great, slow currents, like rivers of light flowing in endless loops. Some currents rise toward the surface, carrying energy upward. Others sink toward the center, bringing cooler material down. This circulation never stops. It has continued for millions of years. It will continue for millions more. The pressure grows stronger as you journey inward, not crushing, but embracing, like being wrapped in the softest blanket imaginable. The star holds you close, sharing its deepest secrets. Now you reach the star's middle layers. Here, the temperature soars to millions of degrees. The pressure is enormous. Yet you feel only wonder, only peace. This is where the real magic happens. You witness something extraordinary. The star is cooking. Not food, but the building blocks of everything. In these middle layers, the star takes simple hydrogen and transforms it, atom by atom, grain by grain, like a cosmic baker working with infinite patience. The process is gentle, despite its incredible power. Two tiny hydrogen atoms drift together through the stellar soup. They touch. They merge. In that moment of joining, they release a spark of energy, a photon of light, a whisper of heat. One such merger means nothing. But billions happen every second. Trillions. More than you could count in a lifetime. Each merger adds to the star's glow. Each tiny spark joins the great symphony of light. The hydrogen atoms, now joined, have become something new. Helium, a slightly heavier element. The star has taken the simplest thing in the universe and made it more complex, more interesting. This is how stars feed themselves, how they create their own fuel. But this process takes time, incredible amounts of time. The journey from the star's core to its surface can take 1,000,000 years. A single photon of light, born in these deep layers, will bounce and dance and wander for eons before it finally escapes. Before it reaches your eyes, you float in this realm of creation, watching the slow dance of atoms, the gentle fusion of elements. This is not violent or harsh. It is patient, methodical, like watching a master craftsman at work. The energy released by each fusion reaction pushes outward. Gently but firmly, this push fights against gravity, which tries to squeeze the star smaller. The two forces balance perfectly. They have balance for millions of years. This balance is why your star shines so steadily, why it burns with such patience. The inward pull of gravity matches the outward push of fusion energy. Perfect equilibrium, perfect harmony. You feel this balance in your own body, the way your breath flows in and out, the way your heart beats steadily in your chest. The star's rhythm becomes your rhythm. Its patience becomes your peace. Deeper still you travel toward the star's very heart. The temperature climbs higher, 10 million degrees, 20 million. The pressure becomes almost unimaginable. Yet the star's core remains stable, controlled, like a perfectly tuned engine. Here, in the innermost regions, the fusion happens faster, more eagerly. The hydrogen burns with quiet intensity. Each second, the star's core converts millions of tons of hydrogen into helium. The energy released could power entire planets. Yet this energy emerges slowly. Gently, it begins its long journey toward the surface, where it will eventually shine as starlight. The light that warms worlds. The light that makes life possible. You rest in this cosmic furnace, marveling at its power and its restraint. This star has burned steadily for so long that entire solar systems have formed and evolved in its light. Planets have been born. Life has emerged. Civilizations have risen and fallen, all powered by this gentle nuclear fire. The star's core pulses around you like a vast, slow heartbeat. Each pulse sends waves of energy rippling outward. You can feel the rhythm in your bones, in your soul. This is the heartbeat of creation itself. But even as you marvel at this stability, you sense something else, something subtle. The star is changing. Very slowly, almost imperceptibly, the balance is shifting. The fuel is not infinite, and time moves even the mightiest stars toward their destiny. You rest in the heart of your star, surrounded by the gentle fire of creation. Here, in this cosmic furnace, you witness something remarkable. A dance, an eternal push and pull that has shaped everything you see. Feel the weight pressing down around you. Not crushing weight, but the patient pull of gravity. Every atom in the star wants to fall inward, toward the center, toward you. This pull is gentle but relentless, like water flowing downhill. It never stops. It never tires. Gravity is the star's embrace. It holds every piece of the star together. Without it, all this glowing gas would simply drift apart into space. The star would vanish like smoke in the wind. But gravity keeps everything close, keeps the family together. You can feel this pull in your own body, the way your feet stay on the ground, the way water falls from the sky, the way your pillow cradles your head at night. Gravity is everywhere, always working, always patient. But here in the star's core, gravity faces a worthy opponent. Around you, the nuclear fire pushes back. Each time hydrogen atoms join together, they create a tiny explosion, not violent or harsh, but firm and steady, like a flower opening its petals, like a bird spreading its wings. The energy wants to expand, to grow, to reach toward the surface. This outward push fights gravity's inward pull. The two forces meet in the middle. They balance perfectly, like dancers holding hands, spinning in slow circles. Neither too strong, neither too weak. Just right. This balance has a name. Scientists call it equilibrium, but you can think of it as peace, as harmony. The star has found its perfect size, its perfect temperature, its perfect brightness. Imagine balancing on a seesaw with a friend. When both of you weigh the same, the seesaw stays level. Neither side goes up or down. That's what's happening in your star. Gravity and nuclear fire have found their perfect balance point. You float in this balanced space, feeling the gentle tug of war around you, the inward pull, the outward push. Back and forth they go like a slow, cosmic heartbeat. like the rhythm of breathing during deep sleep. This balance is why your star shines so steadily. Day after day, year after year, century after century. The same warm glow, the same gentle light. Planets can orbit safely around such a star. Life can take root and grow. But balance requires fuel. The nuclear fire needs hydrogen to keep burning. And hydrogen, like wood in a fireplace, gets used up over time. Very slowly, grain by grain, the star consumes its fuel. Each fusion reaction turns a little hydrogen into helium. At first, this doesn't seem to matter. The star has so much hydrogen. Oceans of it. Mountains of it. Enough to last for billions of years. And it does last. Your star has been burning steadily for longer than Earth has existed. But time moves differently for stars than for us. What seems like forever to a human is just a moment in a star's life. And even the deepest well can eventually run dry. You witness this slow change happening around you. In the star's very center, where the fusion burns hottest, the hydrogen gradually disappears. In its place, helium builds up, like ash in a fireplace, like sediment at the bottom of a river. Helium is heavier than hydrogen, denser. It sinks toward the star's center, creating a small, heavy core. This core doesn't burn. It can't participate in the nuclear fire. It just sits there, growing slowly larger as more helium settles on top. The change is so gradual, you can barely notice it. Like watching grass grow, like watching mountains form. But it's happening, day by day, fusion by fusion. The star's heart is slowly transforming. As the helium core grows, something interesting begins. The star has to work a little harder to maintain its balance. With less hydrogen burning in the center, the nuclear fire weakens slightly. Gravity starts to win the eternal tug of war. But your star is clever. It knows how to adapt. As gravity squeezes the core tighter, the temperature rises. Hotter conditions make the remaining hydrogen burn faster, brighter. The star compensates for its changing heart. You feel this subtle shift in the rhythm around you. The pulse grows slightly faster. The light becomes a tiny bit brighter. Not enough to notice from far away, but here in the core, you sense the change. This is how stars age. Not suddenly like switching off a light, but gradually like the slow turn of seasons. Each year brings small changes. Each million years brings larger ones. The star adapts, adjusts, continues its cosmic dance. The beautiful thing is how patient this process remains. Even as the star ages, it maintains its gentle nature. The light still flows steadily outward. The warmth still reaches across space. The balance, though shifting, still holds. You rest in this slowly evolving heart, marveling at the star's wisdom, how it responds to change without panic, how it finds new ways to keep the fire burning, how it maintains its role as a cosmic lighthouse, even as its inner structure transforms. Around you, the helium continues to collect, grain by grain, drop by drop, building the foundation for what's to come. The star is writing its own future in these tiny accumulations, preparing for the next chapter of its long story. But that future still lies far ahead. For now, the balance holds. The nuclear fire still pushes outward with determination. Gravity still pulls inward with patient strength. The dance continues. You float peacefully in this evolving space, feeling the slow pulse of time itself. Each fusion reaction marking another moment in the star's long journey. Each helium nucleus settling into the growing core like a seed planted for tomorrow. The star has found its rhythm with change, its way of growing older while staying strong. But you sense something else stirring in the depths. A restlessness that speaks of transformation yet to come. As more helium gathers in the core, as the hydrogen shell burns brighter above it, your star begins to dream of a different future. One where the gentle balance of today will give way to something magnificent and strange. Time has passed. Millions of years. Hundreds of millions. You have watched your star burn steadily through countless seasons of cosmic time. But now, floating in its heart, you notice something different. Something has changed. The helium core beneath you has grown. What once was a small seed is now a massive ball of ash. Dense and heavy, it sits at the star's center like a stone at the bottom of a pond. This helium cannot burn. It cannot join the nuclear dance. It simply waits. Around this growing core, a thin shell of hydrogen still burns. But the fuel grows thinner each day, like oil in a lamp running low, like wood in a fireplace burning down to embers. The star's easy abundance is slowly becoming scarcity. You feel the change in the rhythm around you. The general pulse has quickened. The temperature climbs higher. What was once a lazy summer afternoon has become a warm spring day, full of restless energy. Your star is working harder now, much harder. The hydrogen shell burns with increasing desperation, like a candle flame growing brighter before it dies. The nuclear fire races faster, consuming fuel at a tremendous pace. But there is less and less fuel to consume. This is the burden of success. Your star has been too good at its job. For billions of years, it has faithfully converted hydrogen into helium. Now the helium ash weighs heavy at its heart. The very product of the star's burning has become its challenge. Imagine a fireplace filled with ashes from many winters of burning. The ashes pile higher and higher, leaving less room for new wood. Eventually, only a small space remains at the top for flames. That's what's happening in your star's core. The helium ash cannot help with the burning. It sits inert like cold stones. But it does something else. It pulls. Its gravity is strong, much stronger than the hydrogen around it. This heavy core draws everything inward with increasing force. You feel this pull growing stronger each day. The helium core acts like a weight at the bottom of the star, making everything else feel heavier. The hydrogen shell above it gets squeezed tighter, compressed like a spring being wound up. As the hydrogen gets squeezed, it heats up. Physics demands this. When you squeeze something, it grows warmer, like pumping air into a bicycle tire, like compressing a sponge. The tighter the squeeze, the higher the temperature. And higher temperatures make nuclear fusion happen faster. Much faster. The hydrogen atoms collide more often. They fuse more eagerly. The nuclear fire suddenly burns much brighter than before. This creates a strange situation. Your star has less fuel than ever before, but it's burning that fuel faster than ever before. Like a car running out of gas, but somehow going faster and faster. The star has entered a new phase of its life. You witness this transformation from inside the burning shell. The fire around you is no longer gentle and patient. It has become urgent, intense. The fusion reactions happen so quickly they almost blur together. The energy output surges. This energy has to go somewhere. It pushes outward with tremendous force. But it can't easily escape through the heavy helium core below. So it pushes in the only direction it can. Up, toward the star's outer layers. The star's surface begins to feel this pressure. These outer layers, which have rested peacefully for millions of years, suddenly experience a new force from within. Energy floods upward like water bursting from a dam. But the star's outer layers are far from the core. They're cooler, more relaxed. They're not prepared for this sudden rush of energy. Like a sleeping giant being shaken awake, they respond slowly at first. The energy pushes against the star's surface from within. Gravity pulls inward from all directions. For a moment, these forces battle for control. The star trembles on the edge of change. You feel this tension building. The old balance is breaking down. The steady rhythm that lasted for so long begins to waver. Your star is approaching a crossroads, a moment of decision. The hydrogen shell burns brighter still, so bright it hurts to look at directly, even though you're protected here in your cosmic journey. The temperature soars to levels the star has never known before. The pressure builds toward a breaking point, and then something gives way. The star's outer layers, pushed beyond their limits, begin to expand. Slowly at first, then faster. The surface starts to swell outward like a soap bubble, growing larger. The star is beginning its transformation into something magnificent and strange. This expansion comes as a relief, like taking a deep breath after holding it too long. The outer layers have more room to spread out. The pressure decreases. But the star is no longer the same compact, efficient fusion engine it once was. As the outer layers expand, they cool. The surface temperature drops. The star's color begins to shift from white-hot to golden yellow, from yellow toward orange. The change happens gradually, but it's unmistakable. You rise with these expanding layers, carried outward on currents of hot gas. The star's interior is reorganizing itself. The compact core gives way to a more spread-out structure. Your star is becoming something entirely new. The hydrogen in the shell continues to burn frantically, feeding this expansion. But now you can see the future approaching. The fuel cannot last forever. This bright burning phase will eventually exhaust the remaining hydrogen. And when that happens, your star will face its next great challenge. The helium core will have grown even larger, even heavier, and somehow, the star will need to find a new way to keep shining, a new way to balance the forces within. For now, though, the expansion continues. Your star swells larger and larger, preparing to become something the universe has seen many times before, but which never fails to inspire wonder. You rise with the expanding star, carried outward on currents of glowing gas. What was once compact and dense now spreads like honey in warm sunlight. Your star is growing, swelling, becoming something magnificent and strange. The change happens slowly at first, like watching a flower bloom in time-lapse photography. The star's outer layers push gently outward, responding to the fierce energy burning in the hydrogen shell far below. Each day brings the surface a little farther from the core. You drift with these outer layers, feeling their gradual expansion. The gas around you grows thinner, less dense, like climbing a mountain where the air becomes lighter with each step. The star is spreading its mass across a much larger space. As your star expands, something beautiful happens. The surface begins to cool. The fierce white heat softens to golden yellow, then to warm orange, finally to deep, glowing red. Your star is becoming a red giant. This color change is not a flaw or weakness. It's simple physics painted across the cosmos. As the surface moves farther from the hot core, it naturally grows cooler, like stepping back from a campfire. The farther you move, the gentler the warmth becomes. But don't mistake cooler for cold. Even in its red giant phase, your star's surface burns at thousands of degrees. Hot enough to melt any metal you know. Hot enough to boil away oceans. Yet compared to its earlier white-hot fury, this red glow feels almost gentle. You watch the star's diameter grow beyond all imagination. Where once it was roughly the size of our sun, it now swells to dimensions that stagger the mind. Larger than Earth's orbit, larger than Mars. If this were our solar system, the star would swallow Mercury, Venus, and Earth entirely. This is what makes red giants so awe-inspiring. They are gentle monsters, vast beyond comprehension, yet soft in their touch. Their light reaches across impossible distances, but their surface gravity is surprisingly weak, like being embraced by a cloud made of warm light. The expansion creates strange and wonderful effects. The star's surface becomes less defined. Instead of sharp boundary between star and space, you see a gradual fading. The stellar atmosphere extends far into the void, creating a fuzzy, luminous cocoon around the denser core. You drift through these outer layers, marveling at their delicate beauty. Streamers of gas flow outward like cosmic hair blown by stellar winds. These gases carry the star's light far into space, creating a glowing envelope that dwarfs entire solar systems. From the outside, your star now looks completely different. What was once a bright white point has become an enormous red sphere. If planets orbit this star, their skies would be dominated by this crimson giant. Day and night would blur together under its gentle, pervasive glow. But this transformation comes with consequences. Planets that once enjoyed perfect temperatures now find themselves in different circumstances. Worlds that were once warm become hot. Planets that were hot become furnaces. And any worlds unlucky enough to be close to the star face a more dramatic fate. You imagine the silent drama playing out in this stellar system. Rocky planets that have orbited peacefully for billions of years now find their star growing larger in their skies. Day by day, the red giant swells outward, approaching their orbital paths. The process is gradual but inevitable, like watching the tide slowly rise on a beach. At first, the advancing stellar surface is still far away. But time moves differently for stars. What seems slow to cosmic eyes unfolds with certainty. For a planet in the path of this expansion, the end comes gently. The star's thin outer atmosphere arrives first, like the softest whisper of hot wind. Then the density increases. The planet finds itself moving through increasingly thick stellar material. Friction begins to slow the planet's orbit. Its path spirals inward. The world that once raced around its star in days or months now takes longer and longer to complete each circuit. It's like a leaf falling through honey, slowed by the thick medium around it. Eventually, the planet merges with its star, not in a violent collision, but in a gradual embrace. The world's materials mix with the stellar gases, adding their substance to the giant's outer layers. In a way, the planet becomes part of the star that once warmed it. This might sound tragic, but there's beauty in it too. The elements that made up that world, the carbon, oxygen, and metals forged in earlier stellar generations, don't disappear. They become part of the red giant's story. When the star eventually sheds its outer layers, these elements will drift into space, ready to form new worlds. You float through the star's expanded atmosphere, thinking about this cosmic recycling. Nothing is truly lost in the universe. Everything transforms, changes form, becomes part of something new and wonderful. The hydrogen shell continues burning far below you, feeding the star's expansion. But even this expanded structure maintains a kind of balance. The energy pushing outward equals the gravity pulling inward. The star has simply found a new equilibrium at a much larger size. This red giant phase can last for millions of years. Your star will burn steadily at this enormous size, shining its gentle red light across vast distances. It becomes a cosmic lighthouse, visible from far across the galaxy. Other stars in the neighborhood might notice the change. Where once there was a modest white star, now there's a brilliant red beacon. The transformation announces that this star has entered a new phase of life, a more dramatic phase. But red giants, for all their majesty, are not stable forever. Deep in the core, the helium ash continues to build up. More and more helium settles into that dense central region, adding to its mass, adding to its gravity, adding to the pressure at its heart. The hydrogen shell burns brightly, but fuel is not infinite. As the shell consumes the remaining hydrogen, it moves outward through the star's layers. Like a slow-burning fuse, it leaves behind more helium ash as it travels. You sense something building in the star's depths. The helium core grows heavier and hotter. Its gravity strengthens. Its pull becomes more insistent. The core is preparing for something, gathering strength for its own moment of transformation. The red giant phase is beautiful, but it's also temporary. A brief, spectacular interlude in the star's long journey. As you drift through the star's gentle outer layers, you can feel the future approaching. A future where this expanded giant will face its greatest challenge yet. The helium core waits patiently at the star's heart, growing denser and hotter with each passing day, preparing for the moment when it too will join the cosmic dance of creation. You descend back into your star's depths, leaving the gentle red surface behind. Here, in the interior, something miraculous is happening. The simple structure of the star's youth has given way to something far more complex, far more beautiful. Your star has become a cosmic factory, not one furnace, but many, each burning at different temperatures, each creating different elements. Like nested bowls stacked one inside another, layers of nuclear firework in harmony. The helium core at the center has grown massive, heavier than our entire sun, but still cannot burn. Not yet. It sits patient and dense, waiting for its moment. The pressure builds within it day by day. The temperature climbs higher and higher. Above this silent core, the first shell burns. Here, the remaining hydrogen fuses into helium, just as it always has. But now this burning happens in a thin layer, like the flame of a candle. Narrow, but incredibly bright. This shell feeds helium ash down to the core below. You float between these regions, feeling the different energies around you. The hydrogen shell pulses with familiar rhythms, the same gentle fusion that powered your star for billions of years. But now it burns with urgency, knowing its fuel grows thin. Below you, the helium core grows hotter. 100 million degrees, 200 million, 300 million. These temperatures would have been unimaginable in the star's youth. But age brings wisdom, and pressure brings power. Finally, something wonderful happens. The helium core reaches a critical moment, like water suddenly beginning to boil, like a seed finally ready to sprout. The temperature climbs past 100 million degrees, and helium begins to burn. This is a different kind of fire. Helium fusion is more complex than hydrogen burning. It requires much higher temperatures, much greater pressure. But when it begins, it creates something new, something that has never existed in your star before. 3 helium nuclei come together in a delicate dance. They merge in a process that seems almost magical. From this union, carbon is born. The same carbon that forms diamonds. The same carbon that makes life possible on distant worlds. You witness this cosmic alchemy with wonder. Your star has learned to build complexity from simplicity, to create heavier elements from lighter ones. Each fusion reaction adds to the growing collection of carbon in the core. But the star's creativity doesn't stop there. As more helium burns, as more carbon accumulates, new possibilities emerge. Carbon nuclei can capture additional helium atoms. When they do, they transform into something else entirely. Oxygen. Now your star has learned to make the very element that creatures on distant worlds breathe. The oxygen that fills their lungs. The oxygen that feeds their fires. Your star has become a creator of life's essential ingredients. This helium burning creates its own shell of fire. A second layer of nuclear fusion, stacked above the hydrogen shell like floors in a cosmic building. Each shell operates at different temperatures. Each burns different fuel. Each creates different products. The structure is elegant and complex. At the center, fresh carbon and oxygen collect like treasures in a vault. Around this, helium burns to create more carbon and oxygen. Above that, hydrogen burns to create more helium. And far above, the star's vast, red atmosphere glows gently in the void. You move between these layers, marveling at their intricate dance. The helium shell burns much faster than hydrogen ever did. It releases energy in great bursts, like a powerful engine firing in rapid succession. This energy pushes outward, maintaining the star's enormous size. But helium burning is hungry work. It consumes fuel much more quickly than the gentle hydrogen fusion of the star's youth. The helium shell races through its material like fire through dry grass. What once lasted billions of years now lasts only millions. As the helium burns, it leaves behind more and more carbon and oxygen. These heavy elements sink toward the star's center, adding their mass to the growing core. The core becomes denser, more complex, a mixture of elements that didn't exist when the star was young. You feel the increasing complexity around you. Where once there was only hydrogen and helium, now you find carbon and oxygen joining the cosmic soup. Each element brings its own properties, its own possibilities, its own role in the grander story of creation. The star has become a master chef, mixing ingredients with perfect timing. The hydrogen shell provides a steady supply of helium to fuel the layer below. The helium shell transforms this fuel into carbon and oxygen, building the core's complexity. Each process feeds the next in an elegant cycle. But this complexity comes with consequences. The carbon-oxygen core at the star's heart grows heavier, with each passing day. Its gravity strengthens. It pulls more insistently on the shells burning above it. The star must work harder to maintain its balance. The helium shell responds by burning even brighter, even faster. It races to provide the energy needed to support the star's enormous structure. But this increased burning only accelerates the consumption of fuel. The star is caught in a cycle of its own making. You observe this process with a mixture of admiration and concern. Your star has achieved something remarkable. It has learned to create complexity from simplicity, to build the heavy elements that will someday form rocky planets, that will enable life itself. Yet this achievement comes at a cost. The star burns through its helium fuel much more quickly than it ever burned hydrogen. The peaceful billions of years of hydrogen burning have given way to the frantic millions of years of helium burning. The star ages more rapidly now. As you drift through these layered shells, you sense the star's growing restlessness. The carbon-oxygen core continues to grow, to accumulate mass, to exert stronger and stronger gravitational pull. The burning shells work harder to resist this pull, burning brighter and consuming fuel faster. The star has entered a race against time. Can it maintain this complex structure? Can the burning shells provide enough energy to support the vast red giant envelope? Or will the growing core eventually demand even more extreme measures? You feel the tension building in the stellar depths. The hydrogen shell burns its way outward through the star's layers, leaving more helium ash in its wake. The helium shell burns through its fuel at an alarming pace, creating more and more carbon and oxygen. Each day brings new complexity to the star's interior. New elements join the mix. New possibilities emerge. But each day also brings the star closer to its next great transformation. The carbon-oxygen core grows heavier and denser, preparing for whatever comes next. In this cosmic factory, creation and destruction dance together in an eternal waltz, building the future while consuming the past. You descend deeper into your star's heart, past the burning shells, past the carbon and oxygen treasures. Here, in the very center, something profound is happening. Your star has learned to create one more element, the most important element of all, iron. The word itself carries weight, not just physical weight, but cosmic significance. Iron is special, unique among all the elements your star has learned to forge. It represents both triumph and tragedy, the peak of creation and the beginning of the end. Around you, the carbon and oxygen continue their nuclear dance. Carbon captures helium to become oxygen. Oxygen captures helium to become neon. Neon transforms into magnesium. Each step builds heavier elements, climbing the cosmic ladder of complexity. But this ladder has a top rung, a final step beyond which no star can climb through fusion alone. That step is iron. Element 26, the most stable nucleus in the universe. The point where the rules of creation change forever. You watch as your star approaches this cosmic boundary. Silicon burning has begun in the deepest layers, the most advanced fusion process your star will ever achieve. Silicon nuclei break apart and rebuild themselves in complex chains of reactions, creating elements like sulfur, calcium, titanium. And finally, inevitably, iron. The first iron nucleus forms quietly, without fanfare, just another product of nuclear fusion settling into the growing core. But this simple event marks a turning point in your star's existence, a moment of cosmic significance that changes everything. Iron refuses to burn further. It sits inert, unmoved by the extreme temperatures around it. No amount of heat can coax it to fuse with other nuclei and release energy. Iron has reached the bottom of the energy valley, the point of perfect nuclear stability. You feel the silence that iron brings. Where once there was the busy chatter of fusion reactions, now there is stillness. Iron accumulates like snow on a winter morning, grain by grain, nucleus by nucleus, building a foundation that cannot contribute to the star's energy output. This creates a strange paradox. Your star has become incredibly sophisticated. It burns silicon in its core while oxygen burns in a shell above. Helium burns in another shell higher still. Hydrogen burns in the outermost shell. Four different fusion processes running simultaneously, like engines in a complex machine. But the very success of this cosmic factory dooms it. Each reaction creates products that eventually lead to iron. And iron, for all its stability, cannot burn, cannot help, cannot provide the energy the star desperately needs. You observe the growing iron core with a mixture of awe and sadness. This element will someday become the bones of distant worlds, the blood of future creatures, the foundation of entire civilizations. But for your star, iron represents an insurmountable challenge. The iron core grows heavier each day. Its mass increases steadily as the silicon burning continues above. What starts as a small seed quickly becomes a significant portion of the star's center. The core's density climbs to extraordinary levels. Imagine trying to compress a mountain into the size of a city. That's the kind of density building in your star's iron heart. The nuclei pack together more tightly than anywhere else in the universe except the most extreme objects. The iron core becomes a cosmic anvil at the star's center. This density brings incredible gravitational pull. The iron core's gravity reaches out through the star's layers, demanding more and more material. The burning shells above work frantically to resist this pull. They burn brighter and faster, consuming their fuel at an alarming rate. But their efforts only make the problem worse. The faster they burn, the more products they create, more elements that eventually become iron, more mass settling into that growing, silent core. The star is trapped in a cycle of its own making. You drift through the silicon-burning shell, watching the final act of nucleosynthesis. This is the most violent fusion process your star can achieve. Silicon nuclei are torn apart and rebuilt in milliseconds. The temperature soars to billions of degrees. The density becomes almost incomprehensible. Yet even this extreme violence produces beauty. New elements are born in these conditions. Chromium, manganese, cobalt, nickel. The star creates a periodic table of possibilities, each element adding to the growing complexity of matter in the universe. But they all lead to the same destination. Iron, the cosmic dead end, the element that absorbs energy rather than releasing it. Every fusion pathway your star can follow eventually terminates at iron's stable embrace. The contrast between the star's layers becomes stark. Far above you, the red giant's surface glows peacefully. The hydrogen shell burns steadily, unaware of the drama below. The helium shell works efficiently, creating carbon and oxygen as it has for millions of years. But here in the core, silence grows. The iron mass accumulates like water behind a dam. The density climbs toward unimaginable values. The temperature, despite being billions of degrees, cannot coax the iron to burn. The core has become an energy sink, consuming rather than producing. You feel the star's growing desperation. The outer shells burn faster and brighter, trying to support the enormous red giant structure above. But they're fighting a losing battle. Every fusion reaction they complete adds more mass to the iron core below. The core approaches a critical threshold, about 1.5 times the mass of our entire sun, compressed into a sphere the size of Earth. At this density, matter behaves in ways that seem impossible. The iron nuclei are squeezed so tightly they almost touch each other. The star has perhaps seconds left at this extreme density, not years or days or hours. Seconds. The iron core teeters on the edge of a cliff that no force in the universe can prevent it from falling over. Above this growing crisis, the burning shells continue their frantic work. They have no way of knowing that their foundation is about to disappear, that all their desperate burning has only hastened the approaching moment. You rest in this strange calm before the storm, surrounded by the quiet iron and the furious burning shells above. The star has achieved something remarkable in its long life. It has climbed the entire ladder of nuclear fusion, creating every element from helium to iron. But creation has a price, And that price is about to come due in the most spectacular way imaginable. You float in the heart of your star, surrounded by the dense iron core. The burning shells rage above you, desperate to maintain their ancient balance. But something fundamental has changed, something that cannot be undone or reversed. The iron core has reached its limit. For millions of years, your star has grown more complex, more sophisticated, more beautiful. But complexity has a price. And now, in this quiet moment, that price comes due. The iron core weighs as much as our entire sun. It occupies a space no larger than a small city. This incredible density creates pressures beyond imagination. The iron nuclei are squeezed so tightly they can barely exist as separate particles. You feel the moment approaching, like the stillness before a thunderstorm, like the pause between breaths. The entire star seems to sense what's coming. The burning shells continue their frantic work, but there's a tension in their rhythm, a tremor in their cosmic song. The iron core has reached what scientists call the Chandrasekhar limit, a boundary named after a brilliant physicist who understood the mathematics of stellar death. Beyond this limit, no force in the universe can support the core's own weight. But you don't need mathematics to feel what's happening. You sense it in the growing pressure around you, in the way matter behaves at these impossible densities. The iron nuclei are crushed together until they touch, until they can be compressed no further. And then the moment arrives. The core surrenders. It happens faster than thought, faster than light can travel across the star's heart. In less time than it takes to blink, the iron core gives up its struggle against gravity. The foundation that has supported your star's entire structure simply disappears. But first, there's silence. Perfect, absolute silence. For just an instant, everything stops. The nuclear reactions pause. The burning shells hesitate. The star's vast red atmosphere hangs motionless in space. It's as if the entire universe holds its breath, waiting for what comes next. You float in this moment of cosmic suspension. Time seems stretched like taffy. The iron core hovers at the edge of collapse, balanced on the knife's edge between existence and transformation. This is the last moment of your star's old life. The final heartbeat of the giant it has been for so long. In this silence, you can hear the star's entire history. The billions of years of patient hydrogen burning. The millions of years as a red giant. The frantic decades of silicon fusion. All of it led to this single, crystalline moment of perfect stillness. The iron nuclei around you seem to whisper goodbye. They have been the most stable particles in the universe. The end point of stellar creation. The final product of nuclear fusion. But now they face something that will tear them apart. Something that will undo everything the star has built. The silence stretches. 1 second. 2 seconds. In cosmic terms, this is an eternity. Stars don't usually pause. They don't hesitate. They burn steadily for billions of years, following the laws of physics with mechanical precision. But this moment is different. This is the moment when your star faces its destiny. The pressure becomes unbearable. The iron core cannot support its own weight any longer. The force holding iron nuclei together, strong as it is, cannot withstand the gravitational crush. Something has to give way. You feel the first tremor, a vibration in the fabric of space-time itself. The core begins to buckle, to bend, to prepare for its ultimate transformation. The iron nuclei, compressed beyond all reason, start to break apart. The electrons that orbit these nuclei are squeezed closer and closer to the nuclear center. These tiny particles, which normally keep their distance from the nucleus, are forced into direct contact. They merge with protons, creating neutrons. The very atoms are being rewritten. But this process takes energy, tremendous amounts of energy. Energy that must come from somewhere. And there's only one place it can come from. The gravitational energy of the collapsing core itself. The core begins to cool as this energy is consumed. The temperature, which has been billions of degrees, starts to drop. The nuclear fires that have burned for so long begin to fade. The star's heart grows cold, even as it grows impossibly dense. You witness this cosmic phase change with wonder and sadness. The iron core, which has been solid and dependable, starts to behave like something entirely different. The matter becomes so dense that normal physics no longer applies. You are watching the birth of something new, something strange. The collapse accelerates. What began as a gentle surrender becomes an unstoppable avalanche. The core's own gravity pulls it inward with increasing ferocity. There is no force left that can resist this pull. No nuclear fire hot enough to push back. No pressure great enough to provide support. The iron core shrinks from the size of a city to the size of a town. From a town to a neighborhood. The density climbs to values that have no comparison in everyday experience. A teaspoon of this matter would weigh as much as a mountain. But the collapse is not random or chaotic. It follows precise physical laws. The core maintains its spherical shape even as it shrinks. It remains organized, coherent, purposeful in its transformation. The burning shells above remain unaware of the disaster below. They continue their nuclear fusion, creating more iron, adding to a core that no longer exists as they knew it. Light from these shells still travels outward, carrying the star's glow across space as if nothing has changed. But everything has changed. The foundation is gone. The solid iron core that supported the entire stellar structure has become something else entirely, something that cannot support anything. In this moment of ultimate transformation, you prepare to witness the most violent event in the observable universe. The silence breaks. The iron core, which has held its breath for that cosmic instant, suddenly gives way to gravity's relentless pull. What happens next occurs faster than human thought, faster than you can blink. In less than 1 second, your star's heart undergoes the most dramatic transformation in the universe. The collapse begins gently, like the first pebble starting an avalanche. The outer layers of the iron core fall inward, pulled by the immense gravity at the center. As they fall, they accelerate, faster and faster, gaining speed with every fraction of a second. You ride with this collapsing matter, experiencing the most violent event in nature. Yet even in this chaos, there is a strange beauty. The collapse follows perfect mathematical laws. It maintains symmetry. It creates patterns within the destruction. The iron nuclei, which once seemed so solid and permanent, begin to disintegrate. The incredible pressure tears them apart like cotton candy in a hurricane. Protons and neutrons, the building blocks of all atoms, are squeezed together until they touch, until they merge. What's happening is almost unimaginable. The core is turning inside out. The matter that once made up atomic nuclei is being compressed into a single giant nucleus. A nucleus the size of a city, containing more particles than exist in entire solar systems. The density climbs beyond all earthly comparison. If you could take a sugar cube of this matter and place it on Earth, it would weigh as much as a mountain range. A teaspoon would contain the mass of millions of elephants. The core has become denser than the center of an atom. Yet the collapse continues. Gravity is relentless. The infalling matter gains speed as it approaches the center. 20,000 miles per second. 30,000. Speeds that approach a significant fraction of the speed of light itself. The core has become a gravitational monster, devouring itself. You feel the incredible forces at work around you. Space and time themselves begin to bend under the extreme gravity. The very fabric of reality warps like a rubber sheet stretched to its breaking point. Matter and energy behave in ways that seem impossible. The temperature, paradoxically, begins to drop. All the energy that once powered nuclear fusion is being consumed by the collapse itself. The core grows cold, even as it grows unimaginably dense. It's like watching a fire die as it's smothered by its own ash. But this cooling serves a purpose. As the temperature drops, a new kind of particle begins to emerge. Neutrinos, ghostly particles that barely interact with anything. They stream out of the collapsing core in numbers beyond counting. More neutrinos are created in this moment than exist in the rest of the visible universe. These neutrinos carry away energy. Tremendous amounts of energy. They drain heat from the core, like cooling water flowing through a radiator. This energy loss actually helps the collapse, making it easier for gravity to crush the matter into ever higher densities. The core shrinks from the size of Earth to the size of a large city, then to a small city, then to a town. The matter becomes so dense that the normal rules of physics no longer apply. You are witnessing the birth of something entirely new, something that has never existed in the universe before this moment. As the collapse reaches its climax, something extraordinary happens. The matter reaches a point where it cannot be compressed any further. The core has become what scientists call nuclear matter, a state where neutrons are packed as tightly as particles in an atomic nucleus, but spread across miles instead of microscopic distances. This creates the ultimate rebound. The collapsing matter hits this incompressible wall and bounces back, like a rubber ball thrown against concrete, like a wave hitting a seawall. The collapse suddenly reverses direction, but the matter that was falling inward at tremendous speed doesn't stop easily. It crashes into the rebounding core material with unimaginable violence. This collision creates a shock wave, a wall of energy and pressure that begins racing outward through the star's layers. You feel the shock wave as it forms. It's like being at the center of an explosion, but an explosion unlike any other. This shock carries more energy than our sun will produce in its entire lifetime, more energy than entire galaxies generate in a year. And all of it is concentrated in a wave moving outward at thousands of miles per second. The newborn neutron star at the core pulses with this incredible energy. It's only about 12 miles across now, smaller than most cities. It contains more mass than our entire sun. Its gravity is so intense that a marble dropped on its surface would hit with the force of an atomic bomb. The surface of this neutron star is smooth beyond perfection. Any irregularities would be instantly flattened by the incredible gravity. The material is denser than an atomic nucleus, held together by forces that exist nowhere else in the universe. It represents the ultimate triumph of gravity over all other forces. But the neutron star is not the end of the story. It's just the beginning. The shock wave racing outward carries the energy needed for what comes next. As it travels through the star's layers, it encounters the burning shells that are still fusing elements, still creating energy, still unaware of the catastrophe below. The shock wave brings news of the core's transformation. It carries the signature of the neutron star's birth. It announces that the old order has ended and something new has begun. The wave moves at tremendous speed, but it still takes time to travel through the star's vast interior. You follow this shock wave as it races upward through the silicon-burning shell, through the oxygen-burning region, through the neon and carbon layers. Each shell it encounters adds its own energy to the wave. The shock grows stronger as it climbs toward the surface. The star's outer layers remain peaceful for now, still glowing with their gentle red light, still maintaining the illusion of stability. But deep below, a message of transformation races toward them, carrying the power to change everything they have ever known. You ride the shock wave as it races outward from the neutron star's birth. This wall of energy and pressure carries more power than entire civilizations could generate in millennia. Yet it moves with purpose, with direction, like a cosmic messenger carrying news from the stars' transformed heart. The wave travels at thousands of miles per second, but the star is vast. Even at this incredible speed, the journey from core to surface will take time. Hours, perhaps. Time for the wave to encounter each of the star's carefully layered shells. Time for it to transform everything it touches. You feel the wave's immense power around you. It's not chaotic or random. Despite its violence, it maintains structure, organization. The shock front is a perfect sphere, expanding outward with mathematical precision. Nature's laws hold even in this moment of ultimate transformation. The first layer the wave encounters is the silicon-burning shell. Here, just moments ago, the star was creating its final elements: iron, nickel, cobalt. The products of stellar nucleosynthesis were settling peacefully toward the core, adding to the iron heart that no longer exists. The shock wave changes everything. As it passes through the silicon shell, it brings incredible heat and pressure, temperatures that dwarf anything the star has known before, pressures that compress matter beyond its normal limits. In these extreme conditions, new nuclear reactions become possible. You witness a cosmic alchemy unlike anything in the star's peaceful past. The shock wave doesn't just carry energy. It creates energy. The intense heat and pressure forge elements that cannot be made any other way. Elements heavier than iron. Elements that require more energy to create than they release. Gold forms in the heart of this chaos. Platinum and uranium emerge from the nuclear fire. These precious metals, which will someday form the cores of distant worlds, are born in the violence of the shock wave's passage. Beauty arising from destruction. The wave grows stronger as it travels upward. Each burning shell it encounters adds its own energy to the expanding front. The oxygen shell, still faithfully fusing oxygen into silicon, suddenly finds its gentle work transformed into something far more dramatic. The shock wave sweeps through this layer like a cosmic wildfire. The oxygen nuclei, which have been patiently burning for thousands of years, are suddenly caught up in reactions happening millions of times faster than normal. Their energy joins the wave, making it brighter, hotter, more powerful. You feel the growing intensity around you. What began as a rebound from the core collapse has become something much larger. A self-reinforcing wave of nuclear energy that gains strength with each layer it consumes. The star is feeding its own destruction, adding fuel to the fire that will eventually tear it apart. The neon shell falls to the advancing wave. Then the carbon and helium layers. Each contributes its stored nuclear energy to the expanding shock. Each adds its voice to the growing symphony of destruction and creation that races toward the surface. But the wave doesn't just destroy, it preserves. As it tears through each burning shell, it carries the products of that layer's nuclear fusion outward with it. The carbon created over millions of years of helium burning. The oxygen forged in the neon shell. The silicon born in the carbon layers. All of these elements, the star's life's work, are swept up in the wave's embrace. They ride the shock front toward the surface, toward their eventual freedom. The wave has become a cosmic conveyor belt, carrying the ingredients of future worlds outward from their stellar nursery. You marvel at this process of cosmic recycling. The shock wave is both destroyer and preserver. It ends the star's life as a fusion engine, but it ensures that the star's creations will survive, will spread, will become part of new stars, new planets, new possibilities. The wave encounters the helium shell, still burning steadily after millions of years. This layer has been the star's workhorse, faithfully converting helium into carbon and oxygen. Now its long service comes to an end. The shock wave overwhelms the gentle helium fusion with its own fierce energy. But even as it destroys the helium shell structure, the wave preserves its products. The carbon and oxygen created here join the growing collection of elements riding the shock front. They become part of the star's final gift to the galaxy. Higher the wave climbs, through layers that remember the star's younger days, through regions where hydrogen has been burning steadily for billions of years. These outer shells have maintained their ancient rhythms, unaware of the drama playing out below. Until now, the shock wave brings change to these peaceful layers too. The hydrogen fusion, which has proceeded at its own gentle pace for eons, suddenly accelerates. The wave's heat and pressure cause fusion reactions to happen faster than ever before. These outer layers briefly burn brighter than they have in billions of years. You feel the wave beginning to interact with the star's vast outer atmosphere. The red giant's extended envelope, which has glowed peacefully in space for millions of years, starts to feel the first tremors of the approaching disturbance. The surface layers, so far from the core, don't yet understand what's coming. But they sense something. The shock wave has traveled thousands of miles through the star's interior. It has gathered energy from every burning shell. It has collected the products of billions of years of nuclear fusion. It carries the star's entire history in its expanding front. Now it approaches the boundary between the star's interior and its atmosphere. The boundary between the dense burning regions and the thin, extended envelope of the red giant. This is where the wave will face its greatest challenge. The star's atmosphere is vast but tenuous, like trying to push through fog compared to swimming through water. The shock wave, which has maintained its strength through the dense interior, must now find a way to transfer its energy to matter that is spread thin across enormous distances. But the wave has momentum, purpose, the combined energy of a collapsed stellar core and all the burning shells above it. As it reaches toward the surface, it prepares for its most spectacular transformation yet. The shock wave reaches the star's surface. For hours, it has climbed through the dense interior, gathering strength from every layer it touched. Now it encounters the thin atmosphere of the red giant. The vast, gentle envelope that has glowed peacefully for millions of years suddenly faces a wall of energy moving at thousands of miles per second. The collision is spectacular. The shock wave hits the star's atmosphere like a cosmic tsunami striking a shoreline. But instead of water, this wave carries the concentrated energy of a collapsed stellar core. Instead of destroying a beach, it's about to transform your entire star into something the universe has never seen before. You ride this moment of impact, feeling the tremendous forces at work. The shock wave doesn't simply push through the atmosphere. It sets the entire outer layer ablaze. Every atom in the star's envelope suddenly receives more energy than it has ever known. The temperature skyrockets, not to the millions of degrees found in stellar cores, but to billions, tens of billions. The entire atmosphere becomes a nuclear furnace burning at temperatures that dwarf anything the star achieved in its peaceful past. This is not the gentle fusion that powered your star for billions of years. This is explosive nucleosynthesis. Nuclear reactions happening so fast they blur together. The shock wave has turned the star's entire outer layer into a cosmic bomb. The light begins immediately. At first, it's just a brightening. The red giant's gentle glow intensifies, grows warmer, changes color from deep red to orange to yellow. But this is only the beginning. The real explosion is still building strength. As the nuclear fires spread through the atmosphere, the light output increases exponentially. What was one star's worth of brightness becomes 10, then 100, then 1,000. The luminosity climbs beyond all earthly comparison. You witness the birth of a supernova. Your star, which has shone steadily for billions of years, suddenly becomes brighter than 100 billion normal stars, brighter than entire galaxies. If this explosion happened near Earth, it would appear as bright as the full moon, visible even in daytime. But you're not just watching this cosmic fireworks display. You're part of it. The shock wave carries you outward with the exploding stellar material. You ride the expanding fireball as it grows from star-sized to solar system-sized in a matter of hours. The explosion is not random chaos. Even in this moment of ultimate violence, physics maintains its patterns. The supernova expands as a perfect sphere. The shock front maintains its shape as it races outward at thousands of miles per second. The light production is staggering. In the first few seconds, your star releases more energy than it produced in its entire previous lifetime. More energy than our sun will generate over the next 10 billion years. All of this energy pours into space as light, heat, and radiation. From far away, observers would see a new star appear in the sky, a star where none existed before. This new star, the literal meaning of the word nova, would outshine everything else in the heavens. It would be visible across vast distances, announcing the death of a giant to anyone with eyes to see. But this announcement carries a deeper message. The supernova is not just about death. It's about birth, about creation, about the universe preparing for its next act of cosmic recycling. The exploding stellar material carries with it all the elements your star created during its lifetime. the carbon forged in helium burning, the oxygen created in carbon fusion, the silicon built through oxygen burning, even the iron that formed in the star's final moments. All of these elements, locked inside the star for millions of years, are suddenly set free. They ride the shock wave outward at tremendous speeds. They escape the star's gravity well and head into the interstellar medium, into the space between stars. But that's not all. The supernova explosion creates elements that no normal star can make. The incredible energies and pressures forge heavy metals through processes that exist nowhere else in the universe. Gold and platinum form in the chaos. Rare earth elements emerge from the nuclear fire. These precious materials, created in the heart of the explosion, join the lighter elements on their journey into space. The supernova becomes a cosmic seed bank, scattering the ingredients of future worlds across vast distances. You feel yourself carried along with this expanding cloud of stellar material. The shock wave has become a shell of glowing gas, growing larger every second. What started as a single point of light is becoming a nebula, a glowing cloud that will be visible for thousands of years. The energy release continues for days, sometimes weeks. The supernova outshines its entire host galaxy, making it visible from distances of billions of light years. Astronomers on distant worlds point their telescopes toward this cosmic beacon, marveling at the violence and beauty of stellar death. As the days pass, the supernova begins to fade, not because the explosion is ending, but because the expanding shell of material is growing cooler. The incredible temperatures that created the initial burst of light gradually decrease as the explosion spreads across ever larger volumes of space. But even as it fades, the supernova continues to release energy. The radioactive elements created in the explosion decay, producing a steady stream of light and heat. This afterglow will continue for months, then years, keeping the expanding nebula warm and visible. The shock wave carries you ever outward, away from the tiny neutron star left behind at the explosion center. That ultra-dense remnant, only 12 miles across, spins rapidly in the heart of the expanding shell. It has become a pulsar, sending beams of radiation sweeping across space like a cosmic lighthouse. You're now part of something much larger than a single star. You're part of a supernova remnant, an expanding shell of hot gas and stellar debris that will continue to grow for thousands of years. This shell will eventually span dozens of light years, carrying its precious cargo of heavy elements far from its point of origin. Other stars in the region feel the supernova's effects. The shock wave triggers compression in nearby clouds of gas and dust. This compression can cause these clouds to collapse and form new stars, new solar systems, new possibilities for planets and life. Your star's death becomes the catalyst for new stellar births. The elements it created and scattered will be incorporated into these new stars. Some will become the rocky cores of planets. Others will become the organic molecules that make life possible. The supernova's light continues to race across the galaxy, carrying news of this cosmic event to distant worlds. On planets orbiting faraway stars, creatures might look up at their night sky and see a new bright point of light. They're seeing your star's final message, traveling across space at the speed of light. This light carries within it the signature of the elements created and destroyed in the explosion. Each type of atom absorbs and emits light at specific wavelengths, creating a cosmic fingerprint that tells the story of stellar death and rebirth. You drift through the expanding supernova remnant, carried by currents of enriched stellar material. Around you, the universe's greatest recycling program unfolds. Your star's death has become a cosmic gift shop, scattering treasures across the galaxy. The elements flow past you like a gentle river of possibilities. Carbon atoms, forged in the star's helium-burning shell, float peacefully through space. Each one carries the potential to become part of a future world, part of future life. These same carbon atoms might someday form the backbone of organic molecules on distant planets. Oxygen drifts alongside the carbon, created during millions of years of patient nuclear fusion. This oxygen, born in stellar fire, will one day fill alien atmospheres. It will be breathed by creatures not yet imagined. It will help fuel the chemistry of life on worlds that don't yet exist. Iron follows in this cosmic parade. The same iron that formed your star's final, silent core now travels freely through space. Some of these iron atoms will settle into the cores of future planets. Others will become the red blood cells of beings who will look up at stars and wonder about their origins. But the supernova has created even more precious gifts. Gold atoms, forged in the explosion's incredible heat, glitter invisibly as they journey through the void. Each speck of this cosmic gold represents energy and elements that no peaceful star could ever create. Only in the violence of stellar death can such treasures be born. Platinum and silver join the golden stream. Rare earth elements, essential for complex chemistry, spread outward with the expanding shell. The supernova has become a cosmic mint, producing the currency that future worlds will need to purchase complexity, to buy the ingredients of life itself. You watch this slow-motion fireworks display with wonder. The remnant continues to expand, growing larger than entire solar systems. But its expansion is gentle now, majestic, like watching a flower bloom in extreme slow motion, each petal unfolding over thousands of years. The shock wave has traveled far from its violent beginnings. What once moved at thousands of miles per second now cruises at more modest speeds. The initial fury has given way to steady purpose. The remnant carries its cargo of elements with patient determination. As the shell expands, it encounters other residents of the galaxy, clouds of gas and dust that have floated quietly between the stars for millions of years. When the shock wave reaches these clouds, something beautiful happens. The impact compresses the gas clouds, squeezes them like invisible hands gently pressing on cotton balls. This compression raises the temperature and density inside the clouds. Conditions become just right for something new to begin. Gravity takes over from here. The compressed regions start to collapse under their own weight. Slowly at first, then with increasing purpose. These collapsing pockets of gas and dust become stellar nurseries, places where new stars will be born. But these will not be the same kind of stars that once filled the early universe. Those ancient stars were made of only hydrogen and helium. Simple, pure, limited in what they could create. The new stars forming in the supernova's wake have access to a much richer palette. Your star's scattered elements mix with the collapsing gas clouds. Carbon and oxygen become part of the stellar recipe. Iron adds its mass to the gravitational collapse. The heavy elements created in stellar cores and supernova explosions become ingredients in the next generation of stars. These enriched stars will burn differently than their ancestors. They will be able to form rocky planets from the beginning, worlds with solid surfaces, atmospheres rich in complex molecules, oceans that can harbor the chemistry of life. You follow one small portion of the expanding remnant as it encounters a particularly dense gas cloud. The shockwave's arrival sets off a chain reaction of stellar birth. Dozens of new stars begin to form simultaneously, each one incorporating some of your star's legacy into its structure. Around these new stars, disks of material begin to spin, planetary systems in the making. The heavy elements scattered by your star's death settle into these disks. They begin to clump together, to build the rocky cores that will become terrestrial worlds. On one of these future worlds, billions of years from now, iron from your star might form the core of a planet. Carbon atoms might become part of vast organic molecules. Oxygen might fill an atmosphere where complex creatures breathe and think and wonder about the cosmos. The calcium in their bones might have been forged in your star's silicon-burning shell. The gold in their technology might have been created in the supernova's nuclear fire. They'll be made, quite literally, of star stuff, of your star's transformed remains. This is the universe's way of ensuring that nothing is ever truly lost. that every stellar death becomes a cosmic birth announcement. Your star's ending enables countless new beginnings. Its ashes become the foundation for entire worlds. The process happens slowly, gently, with infinite patience. The expanding remnant will continue to grow for thousands of years. The triggered star formation will continue for millions. The new planetary systems will take billions of years to mature. But time moves differently on cosmic scales. What seems impossibly long to human minds is just a moment in the universe's grand story. The supernova remnant is both an ending and a beginning, a period at the end of one sentence and the capital letter starting the next. You drift peacefully through this cosmic transformation, watching your star's elements begin their next adventure. Some will become part of new stars within a few million years. Others will wander the galaxy for billions of years before finding their next home. All around you, the galaxy grows richer, more complex, more interesting. Each supernova adds to this cosmic enrichment program. Each stellar death makes the universe more capable of creating wonders, more able to support the intricate chemistry that life requires. The expanding shell carries forward the story of creation itself. From simple hydrogen and helium, the universe has learned to build complexity, to create elements that enable planets, atmospheres, oceans, and eventually consciousness itself. Your star's light continues to travel across the cosmos, but now it carries a different message than the steady glow of its youth. You slow your cosmic journey and look back toward the center of the expanding supernova remnant. There, in the heart of the glowing shell, something remarkable remains. A monument to your star's transformation, a keeper of memories. The neutron star spins in perfect solitude, 12 miles across, yet containing more mass than our entire sun. It rotates hundreds of times per second, like a cosmic figure skater pulling in her arms. Each rotation sweeps beams of radiation across space, creating a lighthouse that will shine for millions of years. This tiny, dense object is all that remains of your star's original core. Everything else has been scattered to the winds. The vast red giant atmosphere, the layered burning shells, the complex elements forged over billions of years, all gone, traveling outward to seed the galaxy with possibilities. But the neutron star remembers. Its incredible density preserves the memory of the core collapse. Its magnetic field, trillions of times stronger than Earth's, carries the signature of that cosmic violence. Its steady pulse marks time like a celestial metronome, counting the eons since the supernova's birth. You drift away from this stellar lighthouse, following the expanding envelope of scattered elements. The remnant has grown vast now, larger than entire solar systems. Its glowing filaments stretch across dozens of light years, creating one of the most beautiful structures in the galaxy. Within these glowing streams, you recognize old friends. Carbon atoms that once burned in helium shells. Oxygen nuclei that formed through patient fusion. Iron that briefly formed a stellar core before being torn apart and scattered. Each element carries the story of your star's long life and spectacular death. The universe feels different now, richer, more complex. Your star's death has added new possibilities to the cosmic recipe book. Future generations of stars will have access to these heavy elements. They will form rocky planets, create complex chemistry, enable the possibility of life itself. You understand now that you are part of an ancient cycle. Your star was not the first to live and die this way. Billions of years ago, other massive stars followed the same path. They burned through their nuclear fuel, created heavy elements, and exploded as supernovas. Those earlier stellar deaths created the elements that your star incorporated during its formation. The iron that formed its final core. The carbon and oxygen that enabled its complex burning phases. Even the calcium and silicon in its structure came from previous supernovas. Your star was born from the ashes of its ancestors, and now its own ashes will give birth to future stellar generations. This is the universe's way of building complexity. of creating the conditions necessary for worlds, for life, for consciousness. Every atom in your body originated in stellar cores or supernova explosions. The calcium in your bones was forged in a dying star's silicon shell. The iron in your blood was created in a stellar core's final moments. The oxygen you breathe was born in helium fusion. You're made of star stuff. Literally. Your very existence depends on the deaths of massive stars like the one you've just witnessed. Each breath you take contains atoms that once burned in stellar furnaces. Each heartbeat pumps elements created in cosmic violence. This realization fills you with a profound sense of connection. You are not separate from the cosmos. You are part of it. Your atoms have traveled for billions of years through the galaxy, participating in the great cycle of stellar birth and death. The supernova remnant continues to expand around you, but now it feels like a gentle embrace rather than a cosmic explosion. These scattered elements will continue their journey for millions of years. Some will become part of new stars within a few million years. Others will wander the galaxy for billions of years before finding their next home. But all of them will continue the cycle. The universe's patient work of building complexity, of creating the conditions where matter can become aware of itself, where stars can give birth to consciousness. You drift peacefully through this cosmic garden, surrounded by the seeds of future worlds. The supernova's violence has given way to gentle expansion. The explosion's chaos has become organized beauty. What seemed like ending has revealed itself as beginning. In the distance, you see other stars beginning the same journey your star has just completed. Young giants burning hydrogen in their cores. Middle-aged stars expanding into red giants. Ancient stars approaching their own moments of transformation. The cycle continues. It always has. It always will. Each stellar death enriches the galaxy. Each supernova adds new possibilities to the universe's palette. The cosmos grows more complex, more interesting, more capable of creating wonders with each stellar generation. Your star's light continues to travel across space, but now you understand its deeper message. It speaks not just of one star's death, but of the eternal cycle that connects all things. The beautiful, patient process by which the universe creates itself anew, one stellar death at a time.